Hello and welcome guys. Now in this video we will be learning about correlation. I mean how we basically tell that these two particular features are correlating with each other and these two are not, and what are the different type of correlation exist. Okay, so let's understand this thing also, since this is very important for us, because I mean moreover we will be looking at these particular different type of correlation metrics for selecting features in most cases, but there are other methods also that we will talk later. So correlation is a statistical measure that quantifies the strength and direction of relationship between two variables. So it indicates how well the two variables are related to each other. So basically there are two type of correlation. One is Pearson, another one is Spearman rank. So Pearson correlation coefficient, it says it measures the relationship between two continuous variable. Okay, so it ranges from -1 to +1, where -1 indicate perfect negative correlation, +1 indicate a perfect positive correlation, and 0 indicate no correlation. So the formula of Pearson correlation coefficient you can see here. It's R equal to n sigma xy minus sigma x sigma y by square root of n sigma x square minus sigma x square into n y square minus sigma y square. So where R is the Pearson correlation coefficient, n is the number of observations, sigma xy is the number sum of product of the deviation of x and y from their mean. Sigma x and sigma y are the sum of x and y respectively. Sigma x square and sigma y square are the sum of square of x and y respectively. So other one is Spearman rank correlation coefficient. So it basically measures the monotonic relationship between two continuous and ordinary variable. So it ranges from -1 to 1, where -1 indicates a perfect negative monotonic correlation, +1 indicates a perfect positive monotonic correlation, and 0 indicates no monotonic correlation. So the formula of Spearman rank correlation coefficient is tau equal to 1 minus 6 sigma d square by n of n square minus 1. Basically tau represents Spearman rank correlation coefficient, n is the number of observation, d square is the sum of square difference between rank of x and y. So in Spearman rank, you can ask me why 6 is used. So basically in Spearman rank correlation coefficient, 6 is used to calculate the denominator in the formula by finding the correlation coefficient. Specifically the denominator is given by formula of d equal to root of sigma rank x minus rank y whole square. Okay, where rank x and rank y are the rank of the observation in the two variables being compared with each other. So the value 6 is used as a normalization factor to adjust the scale of coefficient, in particular where there are n observation in each variable. So the maximum value of d is n into n square minus 1 by 6, which occur when two variables are perfectly ranked. So that we do by dividing the observed value of d by this maximum value given value between -1 and +1, which is Spearman rank correlation. Now the main difference between Pearson correlation coefficient and Spearman rank correlation coefficient is that Pearson correlation coefficient measures the linear relationship between two variables, while Spearman rank correlation coefficient measures the monotonic relationship between two variables, which is relationship where the variable move in the same direction but not at the constant rate. Additionally, this Pearson correlation coefficient is suitable for continuous variable, while Spearman rank correlation coefficient is suitable for ordinal variable or continuous variable as well that have non-linear relationship. Now let's see this thing in implementation, so that we will be clear when to use which one. I mean I already told you when to use which one. Basically Pearson correlation coefficient is used when we have continuous variable, and Spearman is used when we have ordinal variable as well as continuous variable, because it will help us learn non-linear relationship as well. Okay, so for this correlation what we need is we need to import one different library, that is SciPy, and from SciPy we will be able to use Pearson and Spearman rank correlation function to basically implement it. Otherwise by default when we use data from .core, it is by default used as Pearson correlation. So make sure you remember this, since for Spearman we need to write one more line to do so. Okay, so let's first see the implementation, basic implementation. So by default NumPy will be imported, and then SciPy. So SciPy is like a scientific Python library where we can do all this complex calculation, and they have wrote all the code for us. So we just need to import it and do the implementation. Okay, so we have imported our required libraries. Now let's create a sample. Okay, data1 equal to 15, 20, 25, 30, 35. You can also try out some other data, like whatever you want to to type. So you can use negative, positive, all different type of numbers to try out and understand how this correlation works, when we will be expecting negative correlation, when we will be expecting positive correlation. So those type of understanding will get cleared. Okay, so now we have created our sample data. Now let's calculate the Pearson correlation. Okay, so for Pearson, what we do is from stats we import Pearson function. Okay, Pearson R. Okay, and we have to pass our both the data set, data 1 and data 2. Now for Spearman, same way, just copy this code and just replace the Pearson function with Spearman R. Okay, so that's all. Now let's print out the output. Okay, so since this is continuous data, Pearson will perform best, I guess. Okay, let's see, let's check it out. So we have run it. Okay, which is saying Pearson C is not defined. Okay, so what we see is, okay, one more thing that we have to do is we want to access first value. Okay, now you can see that Pearson showing -1 correlation, which means data 2 and data 1 is negatively correlated, but they are correlated somehow. Okay, it's not like negative correlation doesn't mean like it's not correlating, it's correlating, but change in variable 1 is affecting negatively change in other variable. That is what we can interpret from this value. And then there is Spearman rank, which is somehow close to Pearson correlation. Now let's check it out for categorical data. Okay, so it was continuous data. Okay, so again what we will do, we'll create two data set. So let's create those. Data 1, and here we will pass categorical data. Okay, high, low, medium, high, low. Low, high, okay, so we have created our categorical data. Now we need to define a rank order for this categorical, or you can say ordinal categories. So let's define it. Okay, so rank order equal to, we'll create a dictionary and we'll map low equal to 1, medium equal to 2, and high equal to 3. Okay, so we have defined our rank. Now we need to convert our ordinal data to numerical rank using the rank order dictionary. Okay, and p dot array rank order variant data 1. Same way, copy it, data 2. Okay, now if you want to see the ranks, you can see it here like this. Okay, so high has been mapped for 3, low has been mapped for 1, and medium has been mapped for 2, like that. Okay, now let's calculate the Pearson and Spearman rank correlation. Okay, so for that we'll just copy this line here. Okay, and now what we need to do is we need to just replace the data. Okay, now let's print out what we have got. Now you can see that on ordinal data, Spearman rank correlation is performing good. It is saying that I mean the data 1 and data 2 is more negatively correlated, than Pearson correlation coefficient. Like we have discussed previously, that on ordinal data it has been seen that most of the time Spearman correlation perform best, and and the Pearson correlation perform best on numerical data, or you can say continuous data. So hope we have understood how yeah, and when we should use Pearson and Spearman. Now let's move to another tutorial where we will be learning about assumption. Okay, so thank you.